Alright, so here in this video we're going to pick back up on our 2.6. So where we left off, we are looking at conversion factors and how that factor is a ratio of two equivalent measures in different units. Conversion factor is always equal to 1. And this is what allows us to exchange units and change units to what we're trying to switch over to while doing it in a fair mathematical way, because it's always equal to 1. And when we're multiplying by 1, it does not change the value of the number. Okay, so for 100 yards into meters. Now, this may take a couple steps because looking up here at the chart, I'm not seeing any yards to meters going straight to. So it might take a couple of these. Now, what I see up here is that I've got yards and feet, and then I have feet and meters, so I might need to utilize both of these. And that's okay. So I'm going to start off with 100 yards over 1. And so I want to get rid of yards, so I'm going to put yards in the denominator on this side. And I'm going to go ahead and travel us to feet, and then I will ultimately use the feet to find the meters. So this conversion is used by this right here, to where 1 yard is 3 feet. That came from right there. That's a conversion factor. Now, that will help us remove the yards and get us into feet. Now I would like to go from feet to meters. All right, so I'm going to use this one to where I have 3.28 feet is equal to 1 meter. What this accomplishes is feet get to simplify out. And now I just need to take care of the multiplication of all this, which you can do on the calculator. On the top, I have 100 times 3 times 1 to get 300. All right, 300 meters. All right, there are no units left over in the denominator when I multiply straight across it. I've got 1 times 1 times 3.28. So once we take out a calculator and perform this, to where we have 300 divided by 3.28, we will get that 100 yards is 91.46 meters. All right, now that one took a couple conversions to do, and that's okay. Just remember to set up diagonally the units that you would like to cancel out. And you want to be left over with that unit that you are trying to end with. All right, so let's check this one out. 22,644 inches into miles. Now, this one's also going to take us a couple steps here. And that's okay, because I can go from inches to feet and then feet into miles. So I'm going to do it like that. So I have 22,644 inches over 1. I'm going to want to get that into feet to where there are 12 inches in 1 foot. All right, and then I can bring in the unit that I ultimately want to end with, which is miles. And this is 1 foot. So I need to get feet in the denominator here. I'm going to use my conversion factor. That there is, let me erase these to find it. And slowly. That's not even where it's at. Here it is. 1 mile is 5,280 feet. Okay. Now, here's our setup. Because inches, and inches in the denominator, feet, and feet in the denominator. We're now left over with miles, which is what we wanted. And we will multiply across here in both the numerator and the denominator. In the numerator, we'll be left with the 644 miles divided by, in the denominator, we have 1 times 12 times 5,280 to get this. And then when we divide those two, we get 0.357, so I'm going to round that to 0.36 miles. All right, and it's always nice to make sure this makes sense. Yes, 22,644 inches is a lot of inches, but compared to a mile, and we can see here now, it's roughly about a third, a little more than a third of a mile. There's a ton of inches in a mile. All right. So we can use these concepts as well to help us address some real-world problems. A plumber needs to replace 20 feet of copper piping. When he gets to the supply store, the links are all given in meters. How many meters of piping does he need to purchase? All right. So the way he's trying to buy it, it's not in the same unit, and he doesn't want to buy too much or too little. He can use unit conversions to help find it. All right. So he has 20 feet. It's 20 feet over 1. We know I'm going to put feet in that denominator, and we're trying to get ourselves to meters. All right, and the conversion we have for this is that 1 meter is 3.28 feet. All right, so this will get our feet to cancel out. So really here what's happening is we have 20 divided by 3.28. So that's going to land this plumber at the conclusion that he's going to need 6.1, it was 6.097, rounded up, meters of material. And if we think about this even further, if they sold this in lengths of meter at a time, he'd actually have to buy 7, because 6 wouldn't be enough. It'd fall just a little bit short. He'd have to buy 7 and then kind of chop off the extra portions there. And that's something to consider as well. It didn't specifically ask that in the problem, but that'll be situations you run into as well, to where, one amount gets you, 6 meters wouldn't be enough. 7's obviously too much, but that's okay. We could discard the extra. Okay. An athletic director is laying out a rectangular soccer field to be 60 meters wide and 95 meters long. What are the dimensions of the field to the nearest whole yard? Okay. We're going to need to do 2 separate ones on this, one to address each of the 2 dimensions. So we've got a 60 meters here over 1. And just like on the other side, I'm going to need to go meters to feet and then feet to yard. So I'm going meters here, looking for feet. All right, and this conversion factor from the other side, 1 meter is 3.28 feet. All right, and then I can do feet and yards, to where 1 yard is 3 feet. This works. Meters cancel out, feet cancel out, leaving us our answers in yards. Now when we do the multiplication, I'm going across the numerator and denominator. We have 60 times 3.28 on top, and we get 196.8 divided by 3 from the denominator, and we get 65.6. They asked to the nearest whole yard, 66 yards. So that's the dimension of how wide it is. Okay, so 66 yards wide. And then now we can figure out how long, which will be 95 meters. And where the conversions we'll use here will be the exact same, because we're just working with the other dimension of the field, where there's 1 meter, 3.28 feet. And then we can take it to 3 feet is 1 yard. Multiply across the denominator. We have 95 times 3.28 to get 311.6 divided by the 3 in that denominator. And we get 103.8, so I'll round up to 104 yards long. All right, so those would be the new dimensions: 66 yards wide, 104 yards long. All right, this last problem is interesting. The fastest animal in the animal kingdom, land, is cheetah, but in the sky we have the peregrine falcon with speed of 242 miles per hour. How fast is that in feet per second? The reason that this one is an interesting problem is because we're not just going to have to go from miles to feet, but we're also going to have to go from hour to second. All right, so pay close attention on this one. This is 242 miles per, which denotes division, per 1 hour. So this one doesn't just have a 1 in the denominator, it also has a unit. I'm going to focus on getting into feet first, to where I've got 1 mile. It's 5,280 feet. Okay. So what this is going to allow us to do is, yes, our miles will cancel. We will now be into feet. Now I need to get from hours to second. And I could continue on in one long chain if I wanted to. I'm going to go ahead and simplify this first one first. So when I multiply across the numerators, we have 242 times 5,280. So right now we are at 1,277,760. So 1,277,760 feet per 1 hour. All right, which you can see how fast that is. That is a ton of feet in 1 hour, but it's going very, very quickly. Now I'm going to continue to get this towards second. So with that, I can do 1 hour, because now I'm trying to get rid of hour. And I want my second, because it's per second, to be in the denominator. So 1 hour, there are 60 minutes. All right, so hour would cancel here. And then I can do that there is 1 minute. There's 60 seconds. And finish multiplying across here. All right. So I'm going to have that very large numerator divided by 60 times 60. All right, and 60 times 60 gives us 3,600. So when I take care of that here, of 1,277,760 divided by 3,600, we are now in our correct unit, which is feet per second. And when we divide this out, we get 354.9 feet per second. All right, so that's very fast. So what that's saying is that peregrine falcon is 354 feet above the ground. It could close that distance all the way to the ground if it's dive bombing full speed. It can cover 354.9 feet per second. And if you think about a basketball goal being 10 feet high, if we take that 300, I'll round it down to 350, and divide it by 10, so talking about from the ground to the rim, not the top of the backboard, but from the ground to the rim, that'd be 35 of those basketball goals 10 feet stacked on top of each other, which would go very high into the sky. That's how fast that peregrine falcon is going, that it would cover that entire distance in 1 second.